Fairfax, a renowned expert in beaver ecology whose research and storytelling have helped communities across the country, and I think far beyond across than the country. Yes, yes. Understand the tremendous benefits of beavers and practical strategies for living alongside them. Some quick housekeeping. We're aiming to reserve 20 or 30 minutes at the end for Q&A and discussion. You can put your questions in the Q&A thingy, or at the end, after Dr. Fairfax is done with her presentation, you can just turn your mic on and ask your question. And we are recording this for folks who can't make it today, and we'll send it out to the group here afterwards. But before we hear from Dr. Fairfax, we are excited and really grateful to begin with a brief presentation from a group of bright and passionate U of M students guided by the amazing Mike Cost, who will be telling us about their capstone project on beaver coexistence. And so with that, I'm going to kick it over to Sydney.
Awesome. Thank you so much, Tanya. Evan, whenever you're ready, we can go ahead and present our presentation. But while we do that, I just want to first say thank you, Tanya, for organizing this event, and thank you all for the opportunity to just present our capstone project. Really, today, our goal is to help set the stage for Dr. Emily Fairfax's presentation on the role beaver play in climate resilience, restoring wetlands, and enhancing biodiversity, by first just grounding us in the current local research efforts that our team is actively working toward. You know, we're passionate about this work for a variety of reasons. Beaver provide really a wide range of ecosystem services, and our team is just really eager to explore how these services contribute to building resilient ecosystems in the face of climate change, and how this benefits humans, wildlife, and the environment as a whole. And we're really committed to sharing this knowledge that we gain through this project with our communities in meaningful and accessible ways. So today I'm joined by my team members, Mel, Teresa, Evan, and Cooper, who you'll get to hear from a little bit later, as well as Tanya said, our advisor, Mike Cost. And our capstone project really focuses on promoting coexistence with beavers in the Fleming Creek by first understanding local policy set here in Michigan and elsewhere around the country, and then researching what a beaver capacity could look like in the Fleming Creek, and providing resources surrounding coexistence efforts to our community members. So today, what we'll do, Evan, if you want to go to the next slide, we'll talk through the 3 pillars that we kind of thought up to guide our project and highlight some of the key outcomes we're hoping to achieve as part of our project. And then we'll focus in on 2 deliverables we want to highlight for you all today. The first being a predictive model where we're trying to identify where beavers are most likely to build their dams in the Fleming Creek. And the second one, a proposed beaver management plan that could be tailored for the Ann Arbor area. And with that, I will hand it over to Mel to talk about our project pillars.
Thanks, Sydney. So as Sydney mentioned, our team structured our project around 3 core pillars. The first being policy. So we began examining existing beaver-related policies in Michigan, particularly those from the agencies such as the DNR and Eagle. We also researched how other states manage beaver populations in order to create accessible resources to help landowners, stewards, and community members better understand local regulations and successful solutions from across the country. And then our second pillar is the beaver dam capacity. So with support from the Utah State University, we're trying to develop a model to predict where beavers are most likely to build dams. And this will help us both anticipate potential areas of conflict, as well as promoting ecosystem services that beaver provide, such as water storage, biodiversity, and flood mitigation. And then Cooper will get into this more a little bit to explain the model in a moment. And then finally, our third pillar it's community engagement. So we're working to identify areas of conflict within Ann Arbor through collaboration with local stewards and community members to provide educational tools as well as coexistence strategies. One key example, which Evan and Teresa will walk through shortly, is the Beaver Management Plan. So this includes the decision matrix shown here that ultimately helps guide responses to various coexistence challenges. And then with that, I'll pass it over to Cooper to dive into the Beaver Dam capacity model.
Thanks, Mel. So, as Mel said, a big part of our project and the field work that we were doing for this summer is determining what areas are suitable habitat that beavers will be returning to and constructing dams at in Michigan. The tool that we're using to do this is a type of habitat suitability analysis called the Beaver Restoration Assessment Tool, BRAT for short. This tool uses hydrology, topography, and vegetation data to determine dam capacity for stretches of the waterway. So in the picture here, this is the graphic from our initial run of the BRAT model. This is part of the Huron River watershed, and you can see that all these different little stretches of the waterway are highlighted in different colors, ranging from really low dam capacity in red and orange, all the way up to frequent or pervasive dam capacity in green and blue. And so this BRAT output, along with any other BRAT output for the waterways that have been done with it, can be found on the website Riverscapes Data Exchange. And as Mel mentioned, our main contact for this is at Utah State University, a man named Jordan Gilbert from Riverscapes. He helped us make this initial model. And part of what our field work is this summer is ground truthing the vegetation data in this area for this model to make the model more accurate. So it's important to know where beaver might be returning and estimates of dam capacity in different areas to be better prepared for conflict with humans and to better measure estimates of possible eutrophication mitigation that could be caused by the dams, among other things that beavers provide. So with that, I'm going to hand it off to Teresa and Evan to talk about potential beaver management plans.
Thank you, Cooper. So over the past few weeks, our team has been reviewing existing beaver management plans to better understand the range of strategies and considerations involved in managing human-beaver coexistence. And based on these examples, we've outlined some key components for a potential plan tailored to Ann Arbor. The first one is background and purpose, starting by giving some regional information, basically what makes Ann Arbor unique in terms of its environment, geography, and how land is used. Also highlight how the city values ecosystem services and the well-being of the local community. This can help set the stage of why we even need a beaver management plan. And additionally, it's important to, lay out what we hope to achieve with the plan, like encouraging the ecological benefits, the returning beaver spring, reducing potential conflicts, and making sure whatever we do is sustainable in the long run. And next is context summary. So this section provides a brief history of beavers in the region, including how their presence has changed over time. It also explains the important ecological role they play, like restoring wetlands, increasing biodiversity, while acknowledging the potential downsides such as damage to infrastructure and increased flooding in certain areas. Now I'm going to pass it over to Evan to introduce the other 2 points.
So the next component is the policy review. So this relates to our policy pillar. Essentially, it will be a summary of existing policy in Michigan, as well as on national level, case studies of where policy is going really well in this area. And to kind of highlight the areas in which we're seeing conflict with policy when it comes to beaver management. And then lastly, management plan would include management approaches, including both proactive and reactive approaches, and all of this encompassed in a decision matrix set up like a flow chart. There's lots of great examples of this throughout the presentation. We've had a snapshot of the one from Alberta, which is really excellent. And this would include region-specific scenarios, which we've already heard a lot of from the stewards we've been in contact with. And then lastly, it would include a contact list of all of these great connections we've been making. A major component of our project is to serve as a connecting group. So we want to connect people in states statewide and as well as nationwide. That is the summary of our project. And we're really excited to hand it off to Dr. Emily Fairfax, who actually met at the Beaver conference last month. So yeah, thank you so much for listening, and let us know if you have any questions about our project.
Awesome. Well, thanks for that. I can go ahead and pop my slides up now. So I'll be talking to everyone about Michigan's beavers, and the title of my talk is that they are our architects of resilience, but only if we let them. And I know that letting them is not necessarily always the easiest thing, and so I'll talk a little bit more about how those compromises can look, give you some stories of success and also some stories of struggles. But first, beavers and resilience. I want everyone to just pause for a second and think about what North American rivers look like today. And this is a pretty classic, doesn't matter if this is your specific home river, but this is what we see across North America and especially in the Midwest and the Great Lakes region. Our rivers are generally larger than what you see out west, and we have lots and lots of water overall. And we've confined that water to some pretty small channels. And on some sides, we'll have agriculture. On some sides, we'll have public lands. On some sides, we'll have forest. On some sides, we have houses and cities and developments. We are using our rivers. Our rivers are working spaces. We have also exerted quite a bit of control over our rivers. I think most people would agree that what rivers look like today is not what they looked like in the past. And when we try to imagine the past, sometimes we'll think about something like this. You get these drawings, like this famous one of the Mississippi, where you can see all of the channels the river used to inhabit. You can see all the drainages, the oxbows, the wet spaces, the wetlands, the fringes, the floodplains, everything that the river was touching and interacting with before it was contained. And if you're thinking about something like this, I would say that's a great start, but something is missing. And even in these drawings from the 1800s and the 1700s, and even in the 1600s, something pretty big was missing from our understanding of the North American rivers. Now, I'm a river scientist. I got my PhD in geology. My undergrad was physics and chemistry. I'm a big numbers nerd. And as a river scientist, I love learning about the history of my field. So starting in 1880, we really started expanding the idea of rivers as a scientific domain. We're for the first time using physics and math to describe how floods work, how streams grade, what hydraulic geometry is. We're developing all of these equations and these descriptions of what a river should be. And that's where we have these great names in river science: Strahler, Hack, Horton, Powell, Davis, Gilbert. They're out there on the ground looking at the rivers and making laws to describe them. And the field continues to develop through the 1900s. We're starting to understand how land use affects rivers. We're starting to understand the effects of dams on rivers. We're getting complex responses. Our models are getting more sophisticated. All of this work is what defined my PhD. All of this work is what defines our modern understanding of rivers. And all of this work began when something was very, very recently missing from the landscape. And there were a lot of things missing from the landscape in the 1800s. This was a period of massive change in North America, but it's really important that something was missing in the rivers that was probably pretty controlling of those rivers. So I'm, of course, talking about beavers. And beavers have been out there, being around for a very long time. Sometimes we lose sight of just how long beavers have been engineering. So this is a simplified tree of their evolution with a couple of key dates marked. So we know that tree cutting had to have evolved at least about 25 million years ago, because that's when we first start finding fossilized cut trees, and that's when we see their jaws change to be able to cut through wood. And then sometime between 25 million and 7.5 million years ago, beavers figured out how to build dams. It had to have been at least 7.5 million years ago, because that's when the North American beaver and the Eurasian beaver split. And they are functionally identical beavers, even though they're technically different species. That would be incredibly unlikely for them to evolve all the same suite of behaviors completely independent of one another. So beavers have been out there reshaping the landscape for millions of years. Beavers are not operating on human life cycles. Beavers are operating on geologic lifetimes. And they were operating on geologic spatial scales as well. This is North America's river network. Every blue line you see here is a river, a stream, a tributary, a creek, a brook, whatever you want to call it. About 53% of these are headwater streams. And we know that every single headwater stream in North America was packed with beavers and beaver dams specifically. We also know that all of those larger streams, the non-headwaters, were pretty much packed with beavers, but those beavers were having a little bit harder time building dams, so they would sit their dams in the tributaries and just build their dens and lodges and canals on the main dams. There were so many beavers. They were influencing every corner of this continent. They live in the deserts, they live in the estuaries, they live in the mountains, the forests, the plains, the prairies, the boreal, the subboreal, the Arctic, everything in between. Beavers are one of the most profound ecosystem engineers because they can take any environmental context and make it into their preferred context, wetland. So they were doing this. They were shaping the North American continent for millions and millions of years. And then we killed them. We killed almost all of them. Before the fur trade, we had 100 to 400 million beavers in North America, which corresponds to about 1 billion beaver dams. And I can tell you from working in the river restoration world today that if I wanted to propose a project to go build a billion small dams for ecological restoration, I would probably need 6 billion years to get the permits for that. So this was a really big scale of change that is hard to imagine today because it's so foreign to us to have that kind of large scale distributed infrastructure. So we had lots and lots of beavers. We trapped them. This trapping was for fur. I grew up in Michigan, and I very distinctly remember spending quite a bit of time on the fur trade in elementary school. But we also trapped beavers to control land and people. So this is something that's not talked as much about. Beavers were used as currency. Beavers were used as a tool of westward expansion. Beavers were used as a political pawn. So we were very intentionally trying to eliminate beavers from this continent, and we were very nearly successful. By the late 1800s, there were maybe 100,000 beavers left. It was a tiny fraction of what there used to be. And that time scale of loss, going from 100 to 400 million beavers down to 100,000 in people's lifetimes, this is probably the greatest geologic, geomorphic, hydrologic disturbance that North America had seen since the change in the last ice age. This was the mass removal of dams, of wood, of water, of sediment, all at once. And the rivers all reshaped. They channelized. They lost connection to their floodplains, lakes drained, wetlands drained. And right after all of this happened, Horton and Heck and Strahler and Powell and Davis go out and start describing rivers. So there's this fundamental problem. We had a massive disturbance that's under-recognized and poorly understood, and then we developed all of our science around not what was the state of North America for thousands and thousands to millions of years. We developed it around the disturbed state. And that's what we've been trying to maintain, is this disturbed state. Today, beavers are coming back. We have 10 to 30 million in North America today, which is about 10% of the historic population. We're nowhere near capacity. We'll never be back at capacity. The land has changed too much. We don't have space for 400 million again. There's a lot more people here today. But 10% is not the maximum that we can hold. And that 10% is not evenly distributed. I can tell you right now, Canada is pulling more than their weight in the population of beavers that they are supporting. There are a lot of them up in the boreal and the subboreal. And as you go further south and as you get into our more developed lands, there are fewer and fewer and fewer. I'm in Minnesota, and parts of Minnesota, I would say, are probably pretty close to their modern carrying capacity, specifically up in the Boundary Waters, up in Voyageurs National Park. But then there are parts of Minnesota, like the prairie potholes and like the ag belts and like the Twin Cities, where we are nowhere near our historic capacity. And that's one of the things that's challenging about understanding beaver populations is that I could say Minnesota has a healthy beaver population, and that's true. But I could also say that specifically where I'm at, the Twin Cities beaver population is catastrophically low. And that is true. Beavers don't think about state lines, but we describe things in terms of our states. And thinking about states, beavers are pretty controversial in Michigan today. We know they've been there and they've been there for a long time. One of the coolest studies, I think, of beaver dam longevity came out of Michigan, and it found a 150-year-old map that had mapped out beaver dams and then overlaid the satellite imagery on that and was like, wow, some of these dams are still there. They haven't changed in 150 years. This is a snapshot to what the landscape used to look like when it was full of beavers. People are working to try to live alongside beavers in some places. There's efforts and calls and opinion pieces all over the place for us to think a little bit harder about them and to think more about what they're doing on the landscape and less about just, oh, this is a big rodent I don't like. However, they are still a big rodent that people don't like. People are exploding their dams. People are removing them en masse. Some of this is legal, some of this is not legal, but it doesn't change the fact that this is happening. This is the attitude towards beavers. It's very diverse. It's very difficult to describe in a couple of sentences. There's a lot of opinions about beavers. And beavers are being managed in a lot of different ways in Michigan. So one of the ways that people understand beaver populations is through looking at beaver trappers and beaver harvest. And we have seen decline in beaver harvest over the last couple decades. And some folks may say, well, that's because we have less trappers. But if you look at the harvest per trapper, we're also seeing decline in that. And depending on specific context of how this data was collected and other factors, oftentimes when we see a decline in harvest per trapper, what we are seeing is a decline in beavers. It's not that the trappers are getting worse at trapping beavers, it's harder for them to trap beavers. Often there's not as many beavers to trap. This may not be true everywhere. I know there are parts of northern Michigan that have really healthy beaver populations, and I know there are parts of southern Michigan that have very, very sparse beaver populations. We do remove their dams. Sometimes we remove them for other species. They are famously in conflict with trout in the Great Lakes region. I'll have some more to say about that later. We also, at least in Michigan, have policies around beaver removal and beaver dam removal that send mixed messages. So beaver dams, you're supposed to have a permit to remove them. However, if a beaver is causing damage, you can remove the beaver without a permit. And that's something that I've come across in a number of other states that makes science really hard. Because then when we're looking at these trapper records, we are not accounting for all of those beavers that were removed without a permit. And it makes it very difficult to know, is our population growing? Is it shrinking? Is it staying the same? If we do not know the loss of beavers from the landscape, we cannot know the status of the population. Michigan has a pretty good website on their beaver management and what is allowed and what is the sort of standard steps you should take when you have a beaver conflict. This is on the nuisance wildlife section of their website. And it's acknowledged here that they can do all these really interesting things. They're big fans of engineering, but they can cause damage like flooding and chewing on trees, which is true. They can cause that damage. However, one of the first recommended things for dealing with beaver damage is to eliminate the food sources of the desirable trees. And whenever I see this as a recommended action, I do feel torn about it, because if the concern is the beaver is cutting down the aspen, and then the solution is to cut down all of your aspen, that to me is a difficult thing to reconcile. It's also not good ecologically. Like, the best way to drive beavers away is to have absolutely terrible habitat. And to recommend that people reduce their habitat quality to remove beavers doesn't feel very far forward-looking, in my opinion. However, there's also better suggestions on here. So wrapping your trees in wire fencing is a good thing. Fencing off drains and culverts is a good thing. And then, according to this list, if all things are not going correctly, then pursue a permit for removal. They recommend installing a Clemson pond leveler, which I think is great. Pond levelers are really good technology. I know there are challenges with actually getting those installed, though. So there's a lot of good stuff here. There's a lot of stuff that's kind of mixed messages here, and there's some stuff that's fairly outdated here. So number one, we actually don't recommend Clemson pond levelers anymore. A Clemson pond leveler is a fixed pipe pond leveler, and in the upper Midwest, we have seen these fail over and over and over again because of ice. These were developed in places that had much thinner ice packs. And when we get, 18 inches of ice, 20 inches of ice, that can crack the Clemsons, that can warp the Clemsons, that can rip them out of their position. We instead recommend a flexible pond leveler. This is a very similar design, except it's a corrugated flexible piping instead of a solid pipe. They should last 5 to 10 years with minimal maintenance. They are inexpensive. Getting one of these things installed with labor is typically only a few $1,000s. And these are ecologically integrated. So what that means is this is not going to remove your wetland, but it will mitigate things like flood damage. We also see a lot of complaints about the failure of wrapping trees with wires. We see beavers get through them fairly often. Wire wrapping your trees is very effective. What's not effective is wrapping them with chicken wire. A beaver is going to weigh anywhere from 40 up to 100 pounds as an adult. They can get quite large. And if you are a 70-pound beaver that rears up on your hind legs, you absolutely have the strength and weight to crush chicken wire down. So you need to think about the size of the animal you're trying to fence out. This is not a rabbit. This is a beaver. You also don't want to fence your tree too close, or they'll just stick their little snoots in and chew the tree anyways. And we know this, we've studied this. Even with the least skilled installation, we see really high success rates for preventing beavers from chewing on trees. So there are really good options out there that can solve your conflicts longer term than trapping the beaver. Because when you trap the beaver, next year, you will have another beaver. And then you trap that beaver, and the next year, you will have another beaver. Wrap your tree with chicken wire, you will have a chewed on tree. Wrap your tree with wire fencing, you can now rest easy because that tree is protected and you don't need to worry about it anymore. We're seeing attitudes shift as this kind of information becomes available. Just next door in Wisconsin, there's been a big push to think more about beaver coexistence and non-lethal beaver management. Some of this push has come from grassroots efforts that are really focused on non-single species management and wetland restoration. Some of it is also coming from a very large lawsuit that Wisconsin DNR has found themselves in the middle of, and that USDA APHIS has found themselves in the middle of because of concerns about how the beaver trapping program was being run in that state. It'd be great if we didn't have every state have to go through a huge lawsuit. These have happened out west, they're happening in the Midwest. So I think thinking forward again and looking at our neighbors, seeing what's happened there, and trying to apply lessons learned in every state is a better path forward than getting tied up in a multi-year lawsuit. Additionally, I'll point you all to a PBS NewsHour clip that was just aired a few nights ago. I was on this, I was interviewing it. I go into a lot more detail about beavers and flood management on there, so definitely look this one up if you want to see that. Beavers are gaining recognition in non-Western US areas for what they do specifically for floods and pollution, which are some of our biggest concerns here. But why bother? When I start this conversation with folks, sometimes it's like, oh my gosh, this is so much for a beaver. And it's much easier for me to call my trapper friend and get rid of this beaver. So why should I bother with this? Why do I have to put all this time and effort into living alongside this animal? I would get rid of a skunk or a raccoon if it was bothering me. Why can't I get rid of a beaver just as easily? Well, we have some big stressors coming our way. Climate's changing in a really big way. We will have wetter and shorter winters. We are getting more rain. We are getting less snow. The summers are going to be drier. Everything is going to be hotter, and the storms are going to be a lot flashier. In the Great Lakes region, we have already experienced 2.3 degrees Fahrenheit of warming between 1951 and 2017. This has already occurred. This is not what's on the menu for next week or next year. This is what's been realized. Our frost-free season is already 16 days longer. We already have 14% more precipitation. We already have 35% more heavy precip events. This is the challenge we face. We cannot pretend like we don't see what's coming down the pipe. It's going to be hotter. It's going to be more rain. It's going to be more rain on snow events. We're going to be stressed by floods. We're going to be stressed by summer droughts. How do we think ahead so that we do not find ourselves vulnerable to these disturbances? We're also seeing some of those threats that often get painted as like a Western US problem creeping eastwards. We are seeing warnings about fire conditions. Minnesota has often given me the same refrain of like, oh, fire is not our problem, really, drought's not our problem, really. And then this spring, we had 3 wildfires in northern Minnesota. And now every year, when you look on the fire forecast, northern Minnesota is lit up as somewhere that's probably going to have challenges with wildfire. Northern Minnesota is ecologically very similar to the upper Midwest in general. It is not unique. This is our same subboreal ecosystem. And this is what is burning. We are also seeing a lot of places get fast-tracked on the drought list. And so as these droughts intensify, we are seeing that warming. And this one, I think, takes a moment of just a little more explanation, because when you have a lot of rain, you build up a lot of biomass. And then it feels like, well, even if we have less rain, that's not really the same thing as going months and months and months without rain like you see out west. But because we have so much more vegetation, you don't need to have that long of a drought or that pronounced of a drought for all of those thirsty plants to become dry and to become flammable and then become your fire risk. And then finally, flooding. Flooding is an issue in many places. Our floods are really intense in the Midwest, and wetlands are one of our best defenses against them. And because we've lost so many wetlands, we are setting ourselves up for billions and billions of dollars in flood damage. This is our problem. And beavers could be one of our solutions. So why bother? Beaver dams, beaver canals, beaver wetlands, these are our climate resilient natural infrastructure. So beavers are nature's engineers. I want to explain exactly how they're buffering all these climate impacts, because I am the first person to say that this is not peanut butter and jelly, this is not salt and pepper. Beavers and climate mitigation does not necessarily roll off the tongue, but they are nature's engineers. We can get behind that, so let's start there. This is a classic beaver dammed wetland in the Great Lakes region. We have a lot of different vegetation types here. We have fast water, we have slow water. There's the beaver dam right in the middle of that image. We have weeds and reeds and grasses, pines and deciduous trees. Everything's all kind of mixed together. This is what most of the upper Midwest looked like for a very, very long time. Today, a lot of it looks more like this little drawing. So our streams have simplified, they've degraded, a lot of them have been sized, we've lost connection to the floodplain. When that happens, we lose a lot of habitat. The streams should be able to support quite a bit of floodplain habitat, and today they do not. This is a challenge for us. River restoration, stream restoration, wetland restoration, these are very large industries, and it's expensive to build wetlands, and it's hard to build wetlands if you're a person. If you're not a person, if you're a beaver, it's easy. Beavers see a stream like this and they're like, no problem, I'll build a dam. And they go out and they do it. They don't pull a permit, they don't draw a blueprint, they go out, they build their dam, and then that slows the water down. And when we clear, it's just slowing it down, it does not stop water. Beaver ponds are not stagnant, beaver ponds are not made of concrete and rebar. These are slow water features. It gives the water time to go out into the soil, out into the floodplain, and build back up a little bit of that riparian or streamside ecosystem. Busy as a beaver, though, is a phrase for a real reason. They are not going to stop with just one little dam. They want to expand that. They want the dam to be longer and taller and stronger. They want to have more aquatic area. For those of you that maybe have not spent a lot of time with actual living beavers, I want to take a moment to point out that beavers are very vulnerable on land. This is an animal that is, like I mentioned, 40 up to 100 pounds. They have webbed feet on the back, hands on the front, and a paddle tail coming out the rear end. They are not built for overland travel. Despite being a semi-aquatic rodent, they are truly at home in the aquatic. So all of this engineering they're doing, all of this expansion, is to keep them safe. The more aquatic area they have, the happier they are, the safer they are. As a consequence of that, they are creating a fundamentally different ecosystem. They are shifting a stream into a pond. But the pond isn't the final form of a beaver wetland. Beavers have to at some point venture further away for their food or explore the landscape or defend their territories. And so to do that, instead of walking around on land, they are going to dig canals. Now these beaver canals are like little micro streams, and they radiate outwards from the ponds. They go out into the floodplain laterally. They also connect upstream to downstream longitudinally. Beavers don't want to be crawling all over their dams all the time either, so they like to make water highways for themselves. And that's exactly what these are. These are the water highways. Beavers can swim in them, go get some food, float it back home, just like we did with timber during the timber era, put the logs in the water and float them. It's easier than dragging them overland. So all of this engineering is just the beaver's natural behavior to create a safe habitat for itself. But it also creates a completely different place. It creates a wetland. And wetlands are an incredibly important ecosystem type. They're also incredibly important for other species. That's why beavers are keystone species. They support creation of habitat that a lot of other things would not have without the beaver present. Now, if you were to visit the beaver pond in the field, you'd see something kind of like this. We've got the dam on the left there. That is a separate structure than the beaver's lodge. The dam holds back water. The lodge is what the beavers live in. They do not live in the dam. That's a common misconception. We've got the beaver in the water looking very agile and in control. They're great swimmers, hold their breath for 15 minutes. We've got the beavers in the background chewing on trees, looking a little more cumbersome and awkward on the land, very accurate. And when you see something like this, I think it's fairly reasonable to say, like, yeah, the beavers made a big change here. But climate change is a really big change. Climate change is regional. Climate change is global. Beaver ponds do not have global spatial scale on their own. But they are a lot bigger than people think, and you don't need that many beavers to have a really big impact. This is a video of one of my field sites in northern Minnesota, and that's a beaver lodge with two of my teams standing on it. Now, as the drone lifts in altitude, I want you to take a look at this landscape. The Beaver's Dam is that kind of bright yellowish line that cuts across on the right-hand side. And now as we lift up, a second Beaver Dam is about to come into view. You can see the canals radiating around the floodplain. You can see all the places that dark grayish blue water is connected. This is what it looks like when beavers engineer their landscape. And this is the work of just one family of beavers. That's mom beaver, dad beaver, a handful of teenage beavers, a handful of little baby beavers. And this is about 20% of the territory that this beaver family is maintaining. It does not take a lot of beavers to have a really big impact, and that is both amazing and also one of the reasons why we have so many conflicts with them. It's also one of the reasons why when you manage a beaver, you are not just changing one animal. You are not just choosing to remove or restore one animal. You are making decisions that affect 1 to 2 kilometers of stream length because that's a beaver family's territory. And it's huge. And when you pause the video and you look and you try to connect yourself, get from the beaver lodge to downstream, there are 10,000 different ways to do that. This is not a stream with a dam with a stream with a dam like we build sometimes. This is a fundamentally different, very hydrologically connected landscape. And it's that complexity that they're building that creates the resilience, and it all starts with floods. Now, I've studied mostly drought and wildfire in my work, but what I realized very early on is that you do not get those other benefits until you start with some flood benefits. So here's our stream without beavers. It's simpler, single channel, more narrow riparian corridor around it. And then here's the beaver dam section. It's got that broader pond, it's got the canals going out, it's got connections from upstream to downstream, and a lot more vegetation generally. When you have a flood wave, now this could be from a storm, this could be from a lot of snow melt, this could be from a broken dam somewhere else, this could be from just your normal annual high water events. When that flood wave tries to travel through a degraded stream, it does not have enough space. And if you think about turning on the hose and then putting your thumb over most of that hose opening, you go from having a very manageable and kind of peaceful trickle of water into a very aggressive spray. When you confine a lot of water to too small of a space, it gets a lot more power than you necessarily want to deal with. Same thing here with the flood waves. Too much water, too little space means that instead of that water nicely going downstream and interacting with the ecosystem, instead it rips it to pieces. It just absolutely pulls the banks apart, it cuts that stream away, it washes away vegetation, roads, houses. But when flood waves enter wetlands, especially beaver wetlands, they're going to encounter deeper water and wider water. These canals that are so effective at moving the beavers out onto the floodplain are also very effective at moving water out onto the floodplain. And then that water still does make its way downstream. Remember, they are not stopping it, they're just slowing it. But it takes the power out, it takes a little bit of the edge off, and it gives some of that water time to sink into the soil and go on even longer flow paths. So instead of seeing large-scale erosion and soil loss and scouring, we instead see water being spread, stored, and slowed. Now this is that same concept, stream without beavers and stream with beavers, but this time we're looking with depth. So we have our stream without beavers on the left, stream with beavers on the right. We've got our infiltrating precipitation, so that's going to be your rain or your snowmelt or whatever on the top. Our stream's impact on groundwater system is fairly small. Our beaver pond's impact on the groundwater system is much wider. The pond itself is a larger area, and then every single one of those canals is like a microstream. So effectively, we're pinning the groundwater up at the surface. I've set our water table fairly deep. This is more common in summertime as it gets drawn down, especially if we have a period of drought, which happens a lot. As soon as we cut off precipitation, as soon as we enter a drought period, even if it's just for a few weeks, you start to drop your water table. And all those plants that maybe could access rainfall and could access shallow groundwater, that gets used up, and then there's nothing left for them to reach. And so they start to wilt and wither and dry up. This is the case very often in our streams that don't have wetlands on them, that are more incised. This is not the case where we have beavers. Because they're so effective at slowing down floodwaters and getting it into the soil, there's a lot more water there to begin with. And it gives the vegetation a lot more water they can access. We don't have infiltrating precipitation or rainfall anymore. And this is something that I've studied out west. This is something my colleagues have studied in boreal wetlands. This is something that we've looked at over and over again and can say with confidence, beaver wetlands resist the effects of drought in a uniquely strong way, more so than other wetland types, more so than streams without beavers on them. And then what happens after that, if you're resisting droughts, you will also be resisting fires because fires burn whatever is dry. And in our streams without beavers, we're seeing more drying. We're seeing a lot of that biomass that grows up during that wet period, dry out during the dry period, and becomes super hyper flammable. And then when you have any kind of a spark, a motorcycle, a power line, a campfire, a cigarette, what have you, it'll start a fire, and these riparian zones can be like a wick for it if they're degraded and unhealthy. But where there's beavers, we don't see that. We see them be able to resist the fire and not burn because they resisted the drought and didn't wilt, because they resisted the flood and stored the water. And then after that fire happens, it comes full circle. When things are burned, it's a lot more ash, a lot more sediment moving into your waterway, but the beaver pond can catch it and settle it, and the cycle continues. And this is more than just a conceptual model. I've seen this over and over and over again. The power of beaver wetlands to stop disturbance is truly profound. And when I see photos like this, I took this photo, there's a forest that's been burnt root to tip. This is a high severity fire. And this beaver wetland has stored enough water in the soil and built up enough of a green, lush, healthy riparian zone that it stopped the advance of that fire. That speaks a lot about the strength of the resilience that's been built. It speaks a lot about how much water is getting stored. And it's just one family of beavers that is working the section you see here. You don't need a lot of beavers to have a big impact. And I will admit, I get asked all the time, is this different here? We're in the Midwest, we're in the Great Lakes region. This is different than the American. Yes, Absolutely, we are different than the American West. But there are many ways that we are the same. And one of those ways is fire, and it is drought. So there's a study independent of mine that was conducted in Ontario's Boreal Shield, which is very close to all of us. And they found that 90% of the fire-resistant wetlands were associated with beaver dams. So even in these flat, boggy, soggy landscapes, we're still seeing this effect of beavers controlling hydrology to build resistance and resilience to disturbance. And I've started to look at this myself. For better or for worse, Minnesota is starting to have to confront wildfires. We've had several in the last decade that are notable in size and intensity. And looking at the strength of fire refugia, or the patches that don't burn, I am finding that beaver wetlands here in the Midwest, here in Minnesota, they are not burning. And everything around them, the forests, the wetlands, the streams, it is burning. So beavers are still capable of creating this special, unique type of wetland, even here where we have more wetlands and have more water. And what's really interesting here that's not true out west, and I think this works to our advantage, is that when we have beaver dams that have been abandoned or they've drained and the beavers are not there anymore, we're actually still seeing some baked in fire resistance there. We're still seeing some amount of fire suppression, even at an inactive beaver wetland. And out west, things dry up so quickly that we don't usually see this as much. When they're drained out west, they're suddenly fire vulnerable again. But here in the Midwest, we have this sort of fundamental change to the soil, the ecology, the water that is creating long-standing fire resistance on the landscape. And when I first saw this, I couldn't help but think, back when we had all those beavers, back when the upper Midwest was absolutely packed with them before the fur trade, how much of the landscape we see today, that we farm today, that we recreate on today, that we build on today, still has that baked in fire resistance, or sort of these ghosts of beavers past. I would say probably quite a bit. And if that kind of thing is not particularly compelling for whatever reason, I also want to point out that beavers are really valuable beyond just their value as fur and beyond sort of any perceived loss of value due to their engineering conflicts. So beavers provide a lot of ecosystem services. They help sequester greenhouse gases. They provide recreational hunting and fishing opportunities. They help with water supply, water purification. They moderate extreme events. They provide a lot of habitat. They provision biodiversity. And then there's also non-consumptive recreation. People like to do things at beaver ponds like birdwatch and hang out and kayak. And when somebody went through and put together a lot of analyses about how much dollar-wise these beavers are providing for us, they found it was $179,000 worth of ecosystem services per square mile per year that beavers provide. So this is a renewable. It continues to provide this benefit year after year after year. It's per square mile. Remember, you don't need that many beavers to get this. This value does not include fire benefits at all. This was done before a lot of the fire research. It's also pre-inflation dollars. So let's just up that and say it's probably closer to like $230 at least per square mile per year. It's a lot of value. And even if you're not buying the moderation of extreme events for whatever reason, you think, you know what, beavers and flood, it is different here. Then what about the greenhouse gases? What about the water supply? What about the water purification? What about the recreational hunting and fishing? The number of fishermen who I have talked to that absolutely love to fish beaver ponds, because that's where the huge fish are, is a lot. The number of hunters that I've talked to that describe the best duck hunting they've ever had being in beaver ponds is a lot. We can't ignore that beavers are providing a lot of services just because sometimes we don't like them. And I want to point out a couple of these in more detail. So here, water quality is a really key. And there are water quality concerns with beaver wetlands, and I want to point out some studies that I think point to the benefits they're providing on the water quality front. Number one, people worry a lot about E. coli and water contamination, and they think that maybe beavers are going to make E. coli worse, especially in our agricultural landscapes where we have lots of inputs of E. coli from cows and things like that. A really great study came out this year, back in March, that looked at a bunch of beaver dams in agricultural landscapes, and they actually found that beaver dams filter out an enormous amount of that E. coli. On the order of 90+% of E. coli is filtered out of the water column as it moves through beaver wetlands, and then the downstream water is much, much cleaner and healthier. There have been several studies now looking at metals in beaver wetlands. These metals are oftentimes a byproduct of mining. We have a lot of mines in the region. Mining is one of our major industries, still is. And beaver wetlands are particularly good at sinking out these heavy metals, getting them to bind onto sediments and then burying them within their ponds. And when you go down the research rabbit hole of looking at this and seeing what people are finding about this, If you have beavers doing this, they're living in acid mine drainage. This happens a lot. There's a lot of metals. It's nasty. They're getting buried in their ponds. The beavers are able to survive through that. It's not immediately killing them. Then afterwards, let's say the beavers leave and the dam breaks naturally. They do not find mobilization of those metals. But what they do find is that if we come in and remove the beaver dam all at once, we do mobilize the metals. And this points to a fundamental difference in beaver dam failure mechanisms. Beaver dams are made to withstand huge floods. There's studies from Canada where there have been 2 meters of rain in 3 days, and the beaver dams, the majority of them withstand that. Don't break, they don't breach, they're still in place. That means that every time we go out and scrape away an entire beaver dam in a day, we're basically simulating a 500-year flood event. We're causing major geomorphic changes. We're releasing a huge amount of sediment. At Lake Tahoe, they did a study and they found that every time they scraped out these beaver dams, they got an algal bloom in Tahoe, and they were like, what could possibly be happening? And they realized all the phosphates were getting settled out in the beaver wetlands. And then when they moved the beaver dams and destroyed them, all the phosphates went back to the lake. And so keep them in the wetlands where over time they can be geochemically processed. Don't release them into our larger water bodies. We've also found that beaver wetlands are really good at removing some of our most common agricultural pollutants, including nitrates. Beaver wetlands can support a lot of denitrification processes, so you get a lot of excess nitrate and phosphate coming in from ag runoff. The phosphates get bound and settled. The nitrates go into the soil, where all the little microbes can help turn them back into inert nitrogen gas. These are very well studied impacts of beaver dams. It's been studied out east, it's been studied out west, it's been studied everywhere. We know they're really good at purifying the water or removing contaminants. I also want to point out biodiversity. We are losing a lot of species, and it's hard for us to sometimes understand why. There's a lot of changes happening right now. We are seeing climate change, we are seeing loss of pollinator habitat, we are seeing a lot of problems. But one thing that's really reassuring to me is that beavers are creating really, really good habitat that's not just benefiting them, it's benefiting aquatic biodiversity, it's benefiting the insects, it's benefiting the fish, it's benefiting the birds. They're causing what's called biodiversity spillover, where it's not just in the wetland, but also the forests adjacent to the wetlands that have better biodiversity. And this is really important for us to think about because not everyone will like beavers and not everyone has to like beavers. But if you like birds, if you like trout, if you like insects, then you probably should at least tolerate beavers because that's their home, the beaver wetland. And when you remove the beaver, you're making it harder for those species you do like to survive. So now I want to hit the but what abouts. So these come up a lot. I have talked to a lot of people about beavers. I've given hundreds and hundreds of talks and interviews about beavers, and I've heard a lot of but what about. So I've gone and tried to find answers to all of these questions. So but what about warm water? Do beavers warm up the water? Is this going to hurt the trout? I mentioned early on that trout conflict was one of our biggest issues in the upper Midwest, and we are seeing a lot of research come out lately showing that, in fact, no, it is not a problem. We are not finding elevated temperatures in beaver ponds. We are not finding significantly elevated temperatures below beaver ponds. We do find parts of beaver wetlands that are quite warm because they're the very shallow water environments. And we also find parts of beaver wetlands that are exceptionally cold because that's the deep pools. They also connect really well to the cold groundwater. This has been seen out west with multiple degrees Celsius of cooling happening. And we've also seen this here in the upper Midwest in Wisconsin and in northern Minnesota, where we're not seeing negative thermal effects from the beaver wetlands. Now, there's definitely scenarios where a dam gets abandoned or the beavers are trapped and it starts to drain down, and then you get this much shallower water because they're not maintaining water level anymore. That can absolutely be terrible habitat for trout. Luckily, I don't think most trout are incapable of finding good habitat for themselves. They've lived alongside beavers for at least 7.5 million years doing their dam building. So I think that there's probably some ways for them to navigate this landscape, such as the canals or hanging out in those deep pools. What about diseases? Beaver fever, Giardia, everyone's least favorite. If you talk to anybody about beavers, chances are they've heard that you can get sick from drinking water in a beaver pond. You can get sick from drinking just about any water in the United States that has not been treated, unfortunately. The vast majority of our waters are full of Giardia and full of a lot of other things that we don't want to be drinking. And especially if you scoop your water right by the sediment of the beaver pond, you're going to get sick. There's going to be things there. However, beavers have been unfairly charged with spreading Giardia, and there is science to back this up. Beaver fever was actually coined because some backpackers up in Banff National Park drank water from the bottom of a beaver pond, got really sick with Giardia, went to the hospital, blamed the beavers, thus beaver fever. Turns out it's much more likely, as this little abstract says, that most of the water is contaminated with Giardia that has been sourced from humans and sometimes cows and sometimes dogs. Humans, dogs, and cows can all share types of Giardia, and the other animal that can share that Giardia with us is beavers. So we're actually getting beavers pretty sick with Giardia. Beavers don't feel Giardia as strongly as us. We then drink water from beaver ponds and say, the beavers made it full of Giardia, when we're actually just drinking our own Giardia, which is pretty gross. But all that's to say, most people shouldn't be drinking unfiltered water. This is not a concern. If you actually look at the abundance of Giardia in beavers, it's much lower than, say, in muskrats or other animals. So I think this one's a little bit unfair. They can have it, but no more than any other water body you'd be drinking, which you shouldn't drink without treatment, to be extremely clear. So fish, do beavers eat them? Do they block their movement? No, and no. So this is that beaver wetland that I showed you earlier. Number one, do they eat them? No, beavers are vegetarians. They don't eat fish. That's sort of the end of that story. Do they block their movement? No, generally. So here you can see there's a lot of connectivity in this landscape. Beavers can go around the pond and the dam, so can fish. They can take all the same canals that the beavers can take. We see them do this. We've tagged a lot of fish out in California and West Coast states where they're really concerned with their salmon. And we see fish very happily take beaver canals to bypass the beaver dams. They're pinging on the tracker right below the dam. They do not ping on any of the arrays on the dam, and then they ping really far upstream and they ping in a canal tracker. So we know they use these pathways. We know there are times when they can be a barrier to their movement, and that time is extreme and severe drought. And so in these really strong droughts, you do draw down water, you lose some of that connectivity, and then you have these deep pools in the beaver ponds, which are good holding space for those trout. These trout are not going to be trying to go do their spawning or their movement during the hottest, driest parts of the year anyways. The timing of the runs of a lot of our naturalist fish is timed very nicely with the natural hydrology, allowing them to move upstream and downstream. So we have seen times, especially out west, where severe drought leads to a barrier of movement, but it is relieved as soon as the drought ends, and the fish do not all simply perish. They just hang out in the beaver pond. This is similar to the holding ponds that you can put them in during salmon rescues out west, if you've ever heard of those. What about overpopulation? What if we don't have enough predators? I guarantee you have enough predators. If you have birds and river otters and foxes and coyotes and dogs and to an extent even probably cats. Baby beavers are about this big. They're like a yam and it will grow slowly. Beavers stay home with their parents for 2 to 3 years because they are slow at growing. When they leave home, they're maybe 20 to 40 pounds. They're not even at their maximum size yet. So a lot of the beaver death is actually happening when they're very small, when just about anything can get them. A pike can eat a baby beaver. We have some interesting data from Illinois that I'm showing you here. It was looking at the cause of death of beavers in central Illinois versus southern Illinois. One of these populations is heavily trapped by people. The other one is not. And what we find is that when people are trapping a lot of the beavers, we don't see as much predation because we are picking them off instead. And then when we are not trapping them, a lot of that slack is being picked up by predation. So it's not that we have to be trapping them to still have a lot of beaver mortality. Beaver mortality is going to happen, especially in the young beavers, especially in the dispersing beavers. Once they're full-size adults, there's less mortality, but that's okay because if only half of them are making it to adulthood, then we're probably at about the replacement rate. Beavers only have 1 litter of kits per year. That litter is going to be 1 to 6 individuals. Whittle that down quite a bit, and then they go start their dispersing journey. And that's one of the most dangerous parts of their life because now they're going to encounter one of their biggest threats, which is other beavers. These pictures of tail injuries here, A, B, and C, only one of them is from a predator, B. A and C are from other beavers. Beavers will fight each other to the death to protect their territories. Their territories are 1 to 2 kilometers of stream length or about a quarter mile of lakeshore. Beavers are your best defense against other beavers. They have a very strong self-limiting population through disease that affects just the beavers, through predation that is going to affect those baby beavers, and through fights that are going to break out between the juveniles and the adult beavers. So generally, we do not worry about overpopulation. They're an incredibly self-regulating species. In the UK, they're reintroducing beavers, and there's very few places that are more predator deficient than the UK, and they're still seeing a strong predation signal, mostly from their otters eating all the baby beavers. And then my last one about is, I think this is my last one. What about a study I read from decades ago? So there are lots of studies out there that at the time was the latest best information. However, Reading these studies today, I really encourage people to look at the methods. Look about how these statements are being made. These are two examples from Wisconsin that I've seen cited over and over and over again that I want to point out because it highlights just how different scientific publishing was a while ago. So in one of these, it is said that in the late 1970s and early 1980s, beaver dams on Wisconsin trout streams reached unprecedented densities of more than 1 per mile. We know very clearly that beavers can build 40 dams per kilometer if they have the resources. So there's no scenario where over 1 per mile is an unprecedented density. But this is cited all the time as saying that we have more beavers than we've ever had in Wisconsin. Similarly, in the other one, they talk about how some of the sources of their data were personal contacts with trappers, information in old journals, conservation department records, and talking to people, which is fine. But if you look at who's talked to, none of these people are conservationists, none of these people are indigenous, none of these people are people that would have a longer history of knowledge of beavers. This is knowledge that's being gathered from a biased population. And then it gets quoted over and over and over again to say we have too many beavers. We have more beavers than we've ever had. And that is not true. We may have more beavers than people want today, but we do not have more beavers than we ever had in the upper Midwest. That is not possible. And then I guess the last thing I'll say is what about just waiting? What if we wait till we have some more specific studies, some more case studies? Why don't we just wait so that we can be 100% sure? And I say we don't wait because we don't have time. We are facing extinction crises. We are facing climate crises. We are facing so many challenges, and we do not have the money. We do not have the people to be able to solve all of these ourselves. And it does not look like that situation is getting any better. So we need to start thinking about partnering with nature. When can we do it? When is it not worth it? Be more critical about those pros and cons. Is removing this beaver dam going to be the best thing for you? Or is this a situation where a pond leveler could help? Is this a situation where there's not actually any damage? It's just a perceived threat and nothing bad has happened yet, but we're nervous. Take that step back because we don't have time to do 1,000 studies in Michigan. We don't have time to do 1,000 studies anywhere. We have to make choices now that are going to be life or death for some of these other species. And when we're managing a keystone species that is in control of 2 kilometers of stream length, I think that merits just a little bit more careful thought. So I want to end by saying, think about what our rivers and streams could look like under a changing climate. It truly, honestly, I don't think it matters that much how you're imagining the historic streams. And I don't think it matters that much what they look like today, because we have choices we can make about what they look like tomorrow. And even if maybe 50 years ago, Ed Avery was right, and we had a million more beavers than we've ever had, that doesn't change that today it's a very different world. The ecosystems are shifting. We're going to become oak savanna in southern parts of the state. We're losing the boreal. What does our future actually look like, and how do beavers fit into that? I think we've got 2 clear options, and we sometimes are pursuing options that lead us to the top panel. We're trying to preserve what they looked like before, and we don't want to admit that what they looked like before is often this sort of really controlled, manicured, not healthy state. We like these channelized streams because we can describe them really easy and we can manage them really easy. We shouldn't like them because they're not serving us, and they're not serving nature, and they're not providing benefits anymore. They were good for moving timber. That was great. We moved a lot of logs. It's not working anymore. They could look like this bottom picture, but that requires more thoughtful coexistence, not just with beavers, but with a lot of other species. It requires talking to landowners. It requires understanding the true nature of our conflicts. We can't just say we're different, then not study it. We can't just say we're different, then not do anything. We have to be honest with ourselves about what is a beaver wetland. It's a wetland. Michigan's lost 40% of its wetlands. Why don't we like these ones? Are we building enough to replace the beaver wetlands we lost? Those are the questions to ask ourselves, and those should be what's guiding our management decisions. And then as we make these decisions, let's study them. Let's make sure we're actually getting data about, is this working? Because we have to be nimble, and we have to be basing our choices in science, not on opinions and not on statements from sometimes 100 years ago that no longer apply today. So thanks, and I believe we now have a good amount of time for some questions.
Do you want to MC, or should we just jump in?
Yeah, I think go ahead and jump in. I don't think we have any questions in the Q&A section. So go ahead, turn your mics on. That was incredibly inspiring and informative, Dr. Fairfax. And I'll tell you the word when I think about all the beavers that we killed and the big mess that we've made, I, just hear the word karma in my head repeating over and over. So I know folks here are dealing with some very practical challenges in terms of parks and drains and roads. And so if anyone would like to ask some practical questions or where we start as a community, maybe that's a way to go.
Well, sure. I mean, I can start. So I'm one of the ones struggling with trying to the balance and coexistence. So thank you for the presentation. It was very informative, inspirational. I hope you have a chance to just take a breath here while we ask questions and develop them. So we're just on a learning curve here, and we're trying to go through some of the beaver management plans that have been developed. Justin, who's on this call, is likely going to be tapped for doing one for us shortly. Do you have one that you've seen that works? That I've seen the Park City one and read that one, and that's often held as in very high esteem. Do you have others that you've seen describe options and a decision tree and zones that are okay, zones that require some active input for coexistence, and some where there's zones where you just cannot have them in more urban settings in the Midwest? Do you have any recommendation for a beaver management plan that kind of fits that bill?
I think the best beaver management plan I've seen written is the one from King County in Washington, which is Seattle. And I really like theirs because they fully acknowledge that the urban environment is quite different than talking about public lands or like 10,000, 100,000 acres of forest that no one's living on. And they have a great flowchart of decision making that includes costs and longevity of each decision. So if you choose trapping, what's your cost on that? If you choose dam removal, what's your cost on that? And then how likely are you going to be to pay that cost again next year? And so what's like the lifetime cost of this choice? So I really like that model. They also talk very openly about like beavers are for sure chewing our trees, and in the urban area, we don't like it when they chew their trees. And we already have limited canopy. This is part of our like city cooling. How do we keep our trees here? And sometimes all that means is putting up some fencing, and the beavers move on. If there's not food, they'll leave. They're very driven by their food resources and availability of water habitat. The water is easier to come by. The food can be less so. And you don't have to cut down all of your trees. You can just fence them. I've also seen some really good ones come out. I want to say, so this is a complicated answer. I think Wisconsin had a really good written beaver management plan in their most recent iteration. I thought it was written in a way that was very balanced. However, it was not applied very balanced. And that's one of the reasons they wound up in this lawsuit situation. But they said very clearly, like, step one is look at coexistence. And step two is like, try it and don't panic. And then it's like step X, Y, Z. And then you get the last step in, which is like trap and remove. Not everything is going to be fixable. But if you don't try these other things and like genuinely try them, you will never know. And then you'll be stuck in this black hole treadmill of beaver trapping and removal. There was also a good one. I'm trying to remember where specifically it came from, but it spent a lot of time talking about dam removal methods, which I think needs to be talked about more. When you do take out the whole dam at once, that is a pretty big choice we're making geomorphically and hydrologically to suddenly release all that water, release all the sediment, release everything in there, create mud flats. We're creating a space that is open for invasives. Whereas if you can slowly draw it off through notching instead of doing it all at once, you don't have as high of a risk of that. And I have done a little bit of work in Ohio at Cuyahoga National Park and talk to them about some of the challenges they're facing. And invasive reeds are a big challenge. And one of the things they've noticed is that when beavers are allowed to flood a system, they can raise the water level enough to actually kill off some of the invasive reeds. And that can give people a little bit of a leg up coming in and doing planting of native alders and native other things. But then if you just drain that all off immediately with the dam removal, there's the mud flat for your reeds to come in on. I'll try to figure out exactly where that plan is that was talking about notched removal versus one-time big splashy removals. I don't think Michigan really leans into tannerite for dam removal. I know Wisconsin does, which is an explosive for removing dams. I also recommend against that because I have worked as a weapons engineer on bombs, and I don't think that we need to bomb a beaver dam to remove it. If a beaver could build it with their paws, we can probably get it out with shovels and rakes and things. It's just going to be slower, which is not what everyone wants.
If there's no other questions, can I follow up on when you're going through decision tree and you wind up on in the last box, which is trap and remove, are you talking about lethal removal in those cases? And in an urban setting, is there a preferred option for that? And then if it's not trap and remove or lethal removal, how successful are relocations where they have been done, whether or not in Michigan that's not it's not verboten, but it's nearly impossible.
Yeah. Trap and remove, when I say that, it's going to be whatever is allowed by the state or the jurisdiction that is managing those beavers. In urban areas, I have spoken with quite a few trappers who are receiving resistance to some of the urban trapping because the weight of a beaver that you set your trap for is very similar to the weight of a dog or the weight of a child or the weight of other things that might be walking around that you don't want to go mess with the trap. And when you're in the middle of an urban area and there's parks and this is a place where maybe kids are going to play or dogs are roaming around, like we do see them get hurt by traps, and that stresses the trappers out. They're absolutely not out there trying to trap people's dogs and kids. But the fact of the matter is, like, a beaver trap is designed to kill an animal that weighs 40 to 70 pounds. And they're not the only animal like that could be in urban park spaces. So being really intentional about how a beaver is lethally removed, if it is going to be lethal, I think is important. I know in California, there were places where beavers would be trapped in a live trap and then euthanized when relocation was illegal, because that was going to be safer than trying to do a body grip or a foothold and drown them when that could be drowning something you don't want to be drowned. In terms of relocations, they can be really successful. It's very dependent on how it's done. Beavers have tight family units. Beavers are fussy. They have a very strong annual cycle with the activities they're doing. Michigan has real winters, so if you trap a beaver in November and then drop it off somewhere in November, it's probably going to die. It doesn't have a food cache, it doesn't have a home. You're trapping it in a very, very difficult situation. If you trap just mom and a kit, and then you leave dad and random kit back at the house, a fractured family has a very hard time maintaining their wetlands, and so chances are that both of those groups are going to die. If you can get the whole family, move the whole family into suitable habitat, that's when we actually see fairly good success rates. 50% is not uncommon, which sounds bad, but it's pretty good for a wildlife relocation. We've seen reports of 80, 90% when a lot of steps are taken to make sure you have the whole family, you've set up the site really well, it has beaver dam analogs or other beaver dams at it that are abandoned. It's the perfect time of the year, which is usually going to be early to midsummer, sometimes late summer, depending on when your winters arrive. You can have very high success. I also think in more populated areas, the sentiment towards lethal management of animals is not positive. And to manage public relations around that, I have consulted and worked with some folks that are in college campuses and in really public places, and their people that live there don't want the beaver killed. And the biggest thing for them is making sure that everyone understands every single step has been genuinely tried. Like, trees have been wrapped, a pond leveler has been installed and left in place for a year, and the bridge is still underwater. And at that point, then people are more understanding that this is a true conflict that cannot be solved easily, versus a beaver moves in, it was seen once, and the next day there's traps out. That, I think, is where you start to run into trouble because you lose trust from the public. And then even if lethal management is the right choice in that site, no one's going to be okay with it.
Helpful. Other questions?
I have more, but I wanted to let other people speak.
I have a question if there are no other. Oh, you can go first.
No, please go ahead.
Okay. We had this question come up about the policy surrounding floodplain permitting. And I'm wondering if Number one, if you could kind of define floodplain like geomorphologically a little bit, to kind of get some clarity on that. Number two, if you think that like even in our most conservative estimates of mapping floodplains, are we actually giving rivers enough room when it comes to building human infrastructure? And then looking forward, how will that change as climate change alters flooding regimes? And what's the future of that kind of human structure interacting with floodplains?
Yeah. So when we do floodplain or valley bottom mapping for research, sometimes we'll find methods that suggest going within a 1 meter elevation contour, a 3 meter, a 5 meter elevation contour, and those are just sort of different interpretations of what the floodplain could be. If you really want to know what it is, look at your soil and see where you have floodplain soils. See where you have remnants of having the river having been there in the past and dropping a lot of fines. Um, in a flat place, like a lot of the Midwest, the floodplain's huge. Like it's a big area. And we also have a really unique hydrology as you go further and further north, which is that in some places we're so flat and there's so many lakes that like one event can actually change the direction of water flow through a watershed. Like erosion is happening on scales that can literally shape water flow directions, which makes running models like Brat really hard up north. We've tried doing that as well. It works really well on streams, like it looks like what you all are working on, but start trying to apply it to like lake country and the boundary waters. Brat does not know what to do. So our floodplains are very large. I think that when we map them sometimes for risk, we're looking at the annual occurrence of high water and how high does that water go? Or sometimes it's how high is our 5-year flood? How high is our 10-year flood? I think that that is something we should be cautious with looking forwards because we've already seen our flood intervals not matching their return periods anymore as climate changes. I teach a lesson on how we come up with these sort of what is the 1, 5, 10, 100,000 year flood sizes, and it's done based on like backtracking through our climate history. And obviously something's very different in the last 100 years or so than was for the last several thousand that we can build these curves based on. So I think we have been very conservative with our floodplain mapping and that there's a lot of places that are vulnerable to floods that are not necessarily mapped in our floodplains. I think we build a lot of structures that are not flood resilient and that's a choice we made and we can be better than that. If you look back in human history in North America, people built homes that were on stilts. People built homes that were sort of set up on the high grounds and weren't down in the valley, even though that's the most fertile land and the best for farming and everything like that. We make these choices and they can be justified. We need to farm. We need to feed people. But we also need to understand that puts us at flood risk and just boxing the river into a concrete channel won't stop that flood risk. We've done that to lots of streams and still had catastrophic flooding. I think that it's a really, really big infrastructure question to fix all of our infrastructure to be flood resilient. And it's easier to build more stormwater retention. And stormwater is oftentimes we try to retain it in like depressions or small wetlands or ponds that we're building across the landscape. And one of my favorite moments in the stormwater world was I went to a conference and was looking at a poster about Iowa's stormwater future. And it was this great map of all these little ponds distributed along the river network and how much that was going to help with stormwater problems in the major cities of Iowa. And I was like, oh my gosh, this is so cool. I didn't know there were people working on beavers in Iowa. And the person was like, oh, I don't. We're building these. This is like our plan for building these stormwater ponds, which is great. Like it's a pond. But the price difference between allowing beavers to do that and then supplementing it with our own versus just trying to do all of this pond engineering ourselves, it doesn't make a lot of sense to me. Sometimes beavers will build where we don't want a stormwater pond, and that's a conflict to be managed. But a lot of the times they're building places where we would be trying to do something similar. So thinking of our future with flooding, our best defense is more stormwater infrastructure. That's where our flood threat is. It's really high precipitation events. It's rain on snow events where we can't get it into the groundwater, so we need surface water retention. And that means building wetlands and building ponds. And it's up to us if we want to have beavers do that or if we want to do it ourselves.
Thank you so much, and thank you for your talk. It was lovely.
I think Professor Knudsen and maybe Justin have questions. And
yeah, a quick one for you, Emily. It was really good to hear the studies that looked at some of these big floods and these dams and the resilience there, because it's a concern that I think a lot of municipalities have that I've heard about from other folks. It'd be nice to be able to reference that to folks. do you know, has there been any looks at kind of some cross-referencing of these dam, like what do these big floods look like in places where there are dams, they're not blowing out, and then of course sometimes dams do blow out and cause damage, and then kind of a look at no dams at all, and this is what the flood did.
Yeah, there's one good one from the UK from Alan Puddock, and I can try to grab that citation and send it along to Tanya or someone to pass along to a listserv. And he looked at the ability for beaver ponds in general to attenuate storm flows compared to places that did not have beaver ponds. The UK is really unique in that they're being super controlling of where they're putting beavers versus not, which lends itself really nice to controlled sense. Then Sherry Westbrook's study in Canada did a really good job looking at sort of the magnitude that beavers can attenuate and can handle. It's very large magnitude storm events. I will say from reading about beavers and floods in a lot of different places and from seeing it myself on ground. I lived in California when there were really big atmospheric river events. I've lived in Minnesota when we've had really big storm events. Single isolated beaver dams are really vulnerable. They are not going to be functioning as well as flood resilient natural infrastructure as if you let them build a complex. So a single beaver pond, if it breaks, that water is going downstream. But beavers don't naturally build a single beaver pond. They're naturally going to be building somewhere between 10 and 15 dams, usually a mixture of big ones and little ones. And that's an intentional engineering behavior that they've developed, because if one breaks, there's another one in the way. And if that one breaks, there's another one in the way. And every single one of these is like a speed bump and a force attenuation for that flood wave. And so even if it's starting to break its way through, the odds it's going to bust out the entire complex is very low. But the odds that an individual beaver dam can break is higher. So when you're managing beavers, that's another thing to think about. Is a little bitty that's the policy against flood. It's also their insurance against drought. So that's where they're storing lots of this backup water. And then the last part I'll say about that is that there was a really good study and a very detailed report that came out of Wisconsin that looked at the Milwaukee River watershed, and they did do a comparison of how much more inflation could we have if we're better to provide because we don't have beaver. It was a lot. There's a lot of stormwater dams that are not in the middle of downtown. They're not in everybody's backyard. They're just sort of sprinkled around the landscape.
Can you hear me?
Mm-hmm.
Okay. Yeah, this is Professor Knudsen at Oakland University, where we have a beaver dam, and have spent the last couple of years working with Justin, who's on this call, trying to manage it and come up with a beaver management program for our campus. I have a kind of two related questions, and I'll try to keep it brief. It seems like I'm disappointed to hear that on the DNR website we have a pond leveler being recommended when they don't work, apparently. And I'm also aware of kind of recent upgrades to pond levelers. I know from Alyssa Chott with the Montana Beaver Conflict Resolution Project, who's associated with the National Wildlife Federation, that they're using T-posts now to ground the pond leveler instead of other sort of previous weighted techniques. So it seems like pond levelers are actually kind of being revised and improved over the years. And so I don't know what the new state-of-the-art pond leveler would look like these days. I'm saddened to hear that the Clemson pond leveler is still listed as a viable option. We have not been able to get a pond leveler at Oakland University because of, I'm not sure what. I have been knocking on Eagle's sort of door for 2 years, trying to figure out what is so difficult about putting one in, especially when we want to maintain a wetland. What we were quoted on the bridge by an Eagle representative was basically the definition of a dam in Eagle's statutes is that it's man-made construction. and that the minute that a human being would touch that beaver dam, it would become technically a human-made construction and could not be permitted. So that barrier went up really early on in our process of trying to coexist with our beaver, who thankfully are still around. And yet the DNR has sort of recommended a Clemson pond leveler on there. So the mixed messaging is profoundly confusing. I'm not just a private citizen, I'm faculty on a team of biologists here at Oakland University who are trying to simply understand why it's so difficult to get a flow device installed at just in our biopreserve, which in fact beavers belong in. So I don't know if I've heard that there are permits or maybe flow devices have been installed for research processes and projects, which I'm glad to hear about. But maybe those are research permits. So I don't know how I get a flow device, and that is incredibly frustrating. I don't know, Dr. Fairfax, if you can tell us how to improve our policy here in Michigan, but I would love to know what is the state of the art for a flow device currently.
Yeah, good question. Lots of good concerns. State of the art for a flow device is to make it really tailored to your specific site and to think about what kind of flows you need to accommodate and when can you just allow it to flow over the pond and what do you want your pond level to be at. We've started thinking a lot about flow devices in Minnesota for beaver ponds that are at the inlets or outlets of lakes that have a lot of lakeshore homeowners, and they're worried about large fluctuations in water level, and so maintaining water level is their concern. For those, the pond leveler, a big pipe that goes through that's like corrugated, and you want it to go far enough away on both sides so that the beaver's not going to be perceiving the sound or the feel of flowing water. Those are not always necessary to manage a conflict. So when you have smaller beaver dams, or when it's more about just like we can't let too much area get inundated, but I'm not as hyper specific about having major control over the exact hydraulics of the structure, we're starting to see really good success with notch exclusion fencing. Sometimes the issue is putting a pipe in for DNRs. Like that's the no-go. It's too man-made, but a fence is more okay. Notch exclusion fence, you just notch the dam, take out a chunk of it, put in a fence that kind of is shaped like a barbell. And then they don't like the dam on those trapezoidal ends. It's hard for them, and you maintain a leak through the dam. And then the beaver decides, am I okay with that leak or not? And if they decide not, problem solved. The beaver left. If they decide yes, problem solved. It's not too flooded. We really like those. They take a little bit more maintenance than the pipe because they are more vulnerable to large flood events. It's a fence instead of a weighted pipe that's T-posted in. But you can T-post these notch exclusion fence in as well if that's allowed. I don't know how receptive DNR or Eagle would be to seeing how a pond leveler could be pursued under permit, because I know you can permits to remove them, and if that removal has to be complete. Is there a way to do it as an incomplete removal and create a notch, and then can that notch be modified? I don't know if that's something they're open to. I know that there's a lot of really good folks that are interested in this and can get really bound up in how things are written, and they are not personally able to authorize something, but they see the value in it or see the science in it. I encountered that a lot in California and Oregon and Washington. And so trying to figure out how you can work with the laws and rules and statutes as written is usually step one. And then step two is seeing like, what does it actually take to get like some sort of a special language in here that says, if it's a pond leveler, then this or that, or if it's a pond leveler, follow this slightly separate decision tree. It can be helpful. It is something to be careful about because we saw with beaver dam analogs when those took off, mostly in the Western US, there were people that really tried to abuse the green tape cutting that was done for beaver dam analogs and put in structures that were not beaver dam analogs, that were just full-on dams, and cast it as a beaver dam. So I do think it is something that needs attention on it and needs clear regulations about what is a coexistence device versus what is some other permutation of messing with beaver dams. But that's something that can be talked about in working groups and policy sessions, in conversations with DNR and Eagle and whoever else your regulatory are. It's very valid to feel frustrated, but it's easier to remove the dam than it is to partially remove it and just like put a fence in. I guess if nothing else, you could try to get a removal permit every single year and just notch a beaver dam.
Thank you very much.
Well, thank you. Any other questions? I can't tell if there's anybody here from the road commission, but is there anyone that wants to ask a question on their behalf, or how important the involvement of how we build our roads, how that impacts our beaver population?
I'm Eric Burkholz. I'm the Assistant Director of Engineering here at the Road Commission. Earlier, we had one of our superintendents, Jared Powers, was here. And again, with me being on the engineering side of things, really it would be more of an operation side. They'd be the ones that more so would have the interaction. If we're experiencing road flooding, if we're experiencing, some kind of a issue experience with one of our bridges or our crossroad culverts, that would be more so related to the operations side of the road commission. In my time here, and I've been at the road commission for many, many years, I've actually built quite a few bridges as part of my role here. And I can say that actually we have not, in all the bridges I've built over the years, we've not had to deal with any kind of a concern related to beavers. Certainly had to pull a lot of permits from DNR and from Eagle, but again, not something that I've had to deal with directly. Certainly, I've enjoyed attending. It's been a very interesting conversation. And I was glad that Jared was here because, again, I wanted to make sure somebody from our operations side was here. Should we run into concerns that we believe might be related to beavers, then it's something that we need to approach thoughtfully. And like I say, I don't have any specific questions, but I really enjoyed the conversation and learned a lot more about beavers than I knew before.
It's awesome. I do joke. I get asked sometimes, like, how do I get beavers back if I want them on my land? And I'm like, just build a culvert. They'll be there immediately. They love culverts, which is a huge source of headache because we also love culverts.
Wonderful. Emily, if folks have more time, Harry has another question he'd like to squeeze in, but thank you, Aaron. Thank you for being here. Really appreciate it.
Yeah, I have more time.
Oh, thanks. Good. I'll go. So can you say more about the dynamics over generations? So if we got a family of 6 kids and it's a year or two, and let's let them leave. Half of them are not going to make it. So you got 2 more. One family is going to take up about a mile, it sounds like, of territory.
Mm-hmm.
Do they tend to want rural area if they can? Do they try to be close so they come home for Thanksgiving? What I'm assuming that example, it's urban, but we've had beaver up and down Fleming Creek.
Mm-hmm.
So what does one beaver turn into in 5 years? And is that different? Is the answer? It depends.
The beavers, when they disperse, they're 2 years old to 3 years old. Sometimes if not a lot of home litter, all to let them stay home a little longer. And then when they disperse, they can go 10 kilometers. We've seen them travel over 80 to find habitat. And this has been really fascinating to watch play out in real time. We've tried to do beaver relocations where we'll take a conflict beaver and try to move it to a stream 80 miles away in a different part of the watershed, and it gets dropped off and it goes straight home, which is very not helpful for us. That is not a common thing for them to do that much of a homing mechanism, but the point is they can travel. They can cross watersheds, they can cross mountain divides, they can do what they need to do. Habitat, they will cross roads, they cars a lot. They cannot outrun a vehicle, and they're hard to see because they're brown and lumpy and close to the ground. So when they're dispersing, we would expect about half of them to already be gone. They didn't make it. So if there was four, try to disperse, this was a good litter to start with. Those four, as they go out dispersing, I would say probably half of them are also not going to make it. And so maybe we have two left now. And those two are going to try to set up their brand new life. In a place with winter, the odds that they can first winter, it's hard. If they don't find them before that winter comes, it's even harder because it's a lot of work to get a food cache ready, to get a dam built, to get a lodge built. So there's just a lot of hurdles for them. In the study that I showed the clip of causes of death for beavers, it also had that were being trapped in Illinois, and very, very few beavers were older than 5 years. So we're seeing a lot of beavers not make it. They can survive technically to be 20 years old. In captivity, we've seen beavers, I think 22 is the oldest. In the wild, 10 to 12 years is not absurd at all. That's a very normal lifespan. But in really modified landscapes where there's a lot of people or there's a lot of trapping, we do not usually see them reach that age. They die much younger. And if the family gets fragmented, which happens in places that are trapped, the odds that the whole family dies is much higher. And so there's just a lot of dynamics about the fact that beavers operate as a family unit instead of as individuals and can be disrupted as a family unit that makes it so that predicting the number of beavers that comes from a specific original family very difficult. They will increase beaver on beaver aggression as the density of beavers increases. So if a lot of them start to try to set up in Fleming Creek and they're packed in closer than they should based on their territory size, if you have them spaced like every 1 kilometer, as dispersers move through, they are all going to be chased out. And if they try to stop and settle, they are going to have to fight. And the only scenario where they're allowed to set up at their own dam in this overpopulated section of stream is if they can fight their way in and defend their own territory. And so then it's not common. They're really self-limiting. And if they have to go 25 kilometers or 25 miles to find new habitat, they will. And if they wind up going through farmland where they get trapped every time on that dispersal route, they all die then. And that's your limiter on that population. They take the river networks. If they go through big gauntlets, that's a way that they do not create a very largely increased population. We see places where they have to cross highways or have to cross human-built dams, be big limiters, and sort of stop dispersal along the pathway and stop population growth.
And for the folks that are on the line who are doing research in Fleming Creek, I'm not suggesting that that creek shed has hit saturation. I wouldn't know enough to say that, and I doubt it has. But they've been found over the last 10 years up and down the length of the creek channel.
Another thing on that that's important for researchers to know is that in a single night, the beavers often will check their entire perimeter and their whole territory. So you can see beavers at like kilometer 0, kilometer 0.25, kilometer 0.5, all the way to kilometer 2. And it's just the same beaver over and over, going back and forth. And tracking individuals is difficult. They're really hard to tell apart. If you can catch their tails on the game cameras, you can see the scarring on it if they've gotten into fights. And that's one of the easiest ways to tell individuals apart. Tracking with GPS or other kinds of tags is very hard because they don't really have necks, so it like pops off their head. And if you want to put it on their tail, you drill into their tail and that changes their behavior and it's not good. And the glue rips off after like 3 months. We're trying to do some work at the University of Minnesota, and if we get through this project and it still looks promising, it'd be great to talk about collaboration with putting like a little, basically find my iPhone tag under the fat in their tail so that you could have retention of site fidelity over the course of about 1.5 years would be the battery life on that, and they couldn't pull it out. And it should be less invasive than a big tail mounted GPS, but we're still testing on cadaver beaver tails and need to make sure the placement is not going to harm them.
Well, we're at 2:05, and I want to respect everyone's time. Thank you so much, Dr. Fairfax, for, yes, as Terry said, incredibly inspiring and helpful information. Thank you to our students for really looking forward to the work you get done, and to everybody here today working on next steps on coexistence plans. And I think also we need to talk together about change, the DNR and Eagle, so that we're able to walk our talk, right? If we want for ecosystems and for climate action, that we need our state systems to be supporting that effort. So that'll be another a step for us, as well as our local community working on. Thank you again for your time and all of the incredible information. Any last words from anyone else here? Yes.
Thanks for pulling it together.
Thank you so much. Thank you. Okay, have a great day, everyone.
Thank you, Tanya.
Thank you.
Fairfax.
Thank you.
Thank you.